This is Jabcam. Today we're doing SN1 and SN2 and 31 questions. I've actually done this video already, but I deleted it because I prefer this format. We're going to start with SN2 reactions. Question number 1. Name 3 types of organohalogen compounds. Alkyl halides, aryl halides, and vinylic halides. Question number 2. Describe the character of the CX bond. Fluorine, chlorine, and bromine are a lot more electronegative than carbon. Iodine is closer in electronegativity to carbon. However, because it's such a huge atom, it's easily polarizable. Therefore, all CX bonds are polar bonds. Question number 3. What causes a substitution reaction to occur? As we just said, the CX bond is polar, which means that the carbon of that CX bond is slightly electropositive. Unfortunately, this leaves it susceptible to attack from either a nucleophile or a base, and the result is a substitution reaction. Question number 4. Discuss the leaving group characteristics of halogens. Out of all the CX bonds, the CF bond is the strongest one. Because of that, fluorine is not a good leaving group. However, chlorine, bromine, and iodine are all good leaving groups. Question number 5. When do elimination reactions happen? Elimination reactions? Girl, that ain't even relevant right now. Question number 5. What is the difference between nucleophilicity and basicity? Basicity is measured by the degree of ionization of that base in water. However, nucleophilicity is measured by a nucleophile's ability to cause a substitution reaction. All nucleophiles can act as bases, and all bases can act as nucleophiles. Question number 6. What type of alkyl halides undergo SN2 reactions, and under what conditions? Methyl and primary alkyl halides undergo SN2 reactions readily with a strong base such as a cyanide ion or a hydroxide ion. Secondary alkyl halides can also undergo SN2 reactions. However, tertiary alkyl halides do not undergo SN2 reactions. Question number 7. Name one thing that needs to happen for an SN2 reaction to commence. One thing that needs to happen for an SN2 reaction to commence is that the molecules need to hit each other with the correct orientation. For the SN2 reaction, the nucleophile needs to hit the alkyl halide from the rear end of its head carbon. Nucleophiles like to hit it from the back. Question number 8. How many steps does an SN2 reaction have? 1 step. Question number 9. Describe what happens in that single step. In that single step, the nucleophile comes along and it attacks the alkyl halide from the rear end of its carbon that is attached to the halogen, and in doing so, it displaces that halogen as a halide ion. Question number 10. What is the transition state of an SN2 reaction? This right here is the transition state of an SN2 reaction. Question number 11. Explain what happens in that transition state. 2 things happen. Number 1 is that the bond between the nucleophile and the carbon is being formed. Simultaneously, the CX bond is being broken. Question number 11. What does SN2 stand for, and why are SN2 reactions classed as bimolecular? SN2 stands for substitution nucleophilic bimolecular. I said this before and I'll say it again. Doesn't flow at all. Not at all. SN2 reactions are classed as being bimolecular because there are 2 particles in its transition state. There is both the alkyl halide and the attacking nucleophile. Question number 12. What is the rate equation of an SN2 reaction? This is the rate equation of an SN2 reaction. Question number 13. Describe and explain what the rate equation shows. If you look at the rate equation, you can see that there is both the alkyl halide and the nucleophile. That means that the rate of an SN2 reaction can be affected by the concentration of both of these things. The rate equation also shows that the concentrations of the nucleophile and alkyl halide both have a proportional effect on the rate of reaction. And what that means is that if we were to double the concentration of nucleophile in the reaction mixture, the rate of the SN2 reaction will double. If we were to double the concentration of alkyl halide in that reaction mixture, the rate of the reaction will double. If we were to double the concentration of both nucleophile and alkyl halide, then because both of these things have a proportional effect on the SN2 rate of reaction, we would expect the rate of that reaction to quadruple. Question number 14. What order of kinetics do SN2 reactions follow, and explain why? SN2 reactions follow second order kinetics because there are 2 particles in its rate equation. Question number 15. What is Walden inversion? When that nucleophile attacks the alkyl halide from its rear end, in the transition state of that reaction, the atoms bonded to that carbon flatten out, and in the end product, they flip to the other side of that carbon. This is what we call Walden inversion. Why does Walden inversion happen? In order for substitution to take place, the filled non-bonding orbitals on the nucleophile need to overlap with empty orbitals on that alkyl halide. Now, the only empty orbitals on that alkyl halide are anti-bonding orbitals. The only place suitable bonding can occur between that nucleophilic non-bonding orbital and the alkyl halide is through the anti-bonding lobe that projects from the rear end of the carbon that is adjacent to the halogen. Because that is the only place where suitable overlapping can occur, the result is not retention of the structure, but inversion of the structure. And this is the reason why we see the groups on that alkyl halide flip to the other side in an SN2 reaction. Question number 17. Name 3 things that can affect both the rate and the end product of an SN2 reaction. Structure of alkyl halide, activation energy, and steric hindrance. Question number 18. Explain why each of these things do so. The longer the alkyl group, the slower the reaction. So in terms of substitution, chloromethane will react faster than chloroethane, which will react faster than chloropropane, which will react faster than chlorobutane, etc. Activation energy. If you have an alkyl halide that's able to undergo substitution to form more than one product, then the reaction with the lowest energy transition state and the lowest activation energy will be faster. Its products will predominate in the reaction mixture. Steric hindrance. As you go from a methyl alkyl halide to a primary alkyl halide to a secondary alkyl halide, the rate of substitution decreases. This is because of steric hindrance. It's just too crowded, and a crowded molecule will basically have a more higher energy transition state. This is why tertiary alkyl halides do not undergo SN2 reactions, because the transition state of that tertiary alkyl halide undergoing substitution will be of too high energy. Number 19. Which alkyl halides undergo SN1 reactions? Tertiary alkyl halides. Question number 20. What is the first step of an SN1 reaction? The first step of an SN1 reaction is the cleavage of the alkyl halide into a carbocation and a halide ion. 21. How many transition states do SN1 reactions have? 2 transition states. 22. What is the first transition state of an SN1 reaction? This is the first transition state of an SN1 reaction. 23. Are there any intermediates in an SN1 reaction? Yes. Yes, there are. There are. Question number 24. What is the intermediate of an SN1 reaction? The intermediate of an SN1 reaction is the carbocation formed in the first step. 25. What is the second step of an SN1 reaction? The second step is the reaction of that carbocation with a base to form a protonated alcohol. 26. What is the second transition state in an SN1 reaction? This is the second transition state in an SN1 reaction. 27. Have a slice of heaven. 10 plus 1, I know that is 11. Oh. Do you remember the Harlem Shake? What is the third and final step of an SN1 reaction? The final step of an SN1 reaction is the loss of a proton on that protonated alcohol in a rapid acid-base reaction with a solvent to yield the unprotonated alcohol. 28. What is the rate equation for an SN1 reaction? Behold, this is the rate equation for an SN1 reaction. 29. Explain what the rate equation shows. So if we look at the rate equation, we can only see one particle, and that is the alkyl halide. What does that mean though? Now that means that only the concentration of alkyl halide can affect the rate of an SN1 reaction. For an SN1 reaction to happen, carbocations need to be present in the reaction mixture. You can double or triple or quadruple the concentration of nucleophile. However, if there are no carbocations for those nucleophiles to attack or react with, then that substitution is not going to take place. The concentration of carbocation in the reaction mixture is directly dependent on the concentration of alkyl halide in that reaction mixture, and this is what the rate equation shows. 28. Describe and explain patterns in carbocation stability. As you go from methyl to primary to secondary and down to tertiary carbocations, the stability increases. So a tertiary carbocation will be more stable than a secondary carbocation, which will be more stable than a primary carbocation, which is more stable than a methyl carbocation. As you go down from a methyl carbocation to a tertiary carbocation, the amount of atoms attached to that positively charged carbon increase. More atoms means more electrons to help disperse that positive charge, and the result is a lower energy, more stable carbocation. Question number 30. What can happen when a secondary alkyl halide reacts in an SN1 reaction? It can form different products due to carbocation rearrangement. 31. What is the 1-2 shift and when does this happen? The 1-2 shift is the rearrangement of atoms on two adjacent carbon atoms to form a lower energy and more stable carbocation. 32. Give an example of this. Here we have 2-bromo-3,3-dimethyl-butane reacting with methanol to yield two products. This is product number 1, 2-methoxy-3,3-dimethylbutane. This is what we would expect. Substitution has occurred on the carbon that previously held the halogen in the original alkyl halide. However, this is not the predominant product. This is 2-methoxy-2,3-dimethylbutane. This is the unexpected product. However, it is predominantly produced over our expected product. If we look at this product, we'll see that substitution hasn't occurred on the carbon atom that held the halogen in the original alkyl halide. Substitution has occurred on the carbon atom adjacent to that carbon atom. To understand why and how that happens, we can look at the carbocations that led to the formation of these two products. When we look at these carbocations, we can see that the unexpected product has been formed from a 1-2 shift that occurred on the original carbocation. In this case, it's a methyl shift because it was a methyl group that was shifted. By looking at the carbocations, we can see why this shift was more favorable. The original carbocation and the carbocation that went on to form the expected product is a secondary carbocation. However, the rearranged carbocation that goes on to form the unexpected product is a tertiary carbocation and hence more stable than that secondary carbocation. Previously, we had discussed that as you go from a methyl to a primary to a secondary to a tertiary carbocation, the stability increases. So that reaction has opted to go for a lower energy, more stable carbocation that has yielded a product different from what we would have expected. And that is an example of how the 1-2 shift can work in an SN1 reaction. And that, guys, is SN1 and SN2 reactions in a nutshell. We're finished now.